Click the bell icon to get latest videos from Ekeeda.
Welcome back, friends. Welcome to the subject of machine design 1. We are right now learning the design of a screw press, which is a kind of power screw, numerical on it. And last time we have seen the design part of the screw, and we have concluded up to the safety of that particular screw based on the principal stress. In today's session, we are going to look quickly at the shear stress safety of that particular screw, and then we are going to derive few more dimensions of it. So let us start with it. What we have is we are looking at the shear stress failure of that particular. Again, from PhD data book, you can refer to the section of power screws where you will find the shear failure criteria, and that says the tau that is induced is equal to, you need not write induced because when you make brackets around, that makes it's a design one, and without bracket it's the induced one, actual one. So the formula says it is the load divided by, we are considering the outermost diameter for this, as this particular thing increases, right, this particular thing decreases, that is how we have to look at it, into H into N. N is the number of threads, of course. So let us substitute the values that we have. The value for the outer diameter we have already found out, if you can remember it. We had certain findings. So based on that, we are using this particular value, diameter. So it's 40. The value H we had found out was 3.5, and the value of N, that is number of threads, is 11. And based on this calculation, the tau value that we get is somewhere around 6.2 Newton per millimeter square. Now this is what the induced value of shear stress. Now we know that for ductile materials, shear stress is almost equal to the half value of the yield stress, and hence the allowable value, let's put them in bracket for the convenience, will be half the allowable value of stress. So the allowable value in our case was somewhere around 86.4. So this value comes out to be 43.2 Newton per millimeter square. So that is what the allowable value of tau. So as comparing it, this value of tau with the value of tau that we have received, the value of tau we have found out, we can say that the tau which is induced is much smaller than tau which is allowed, and hence I'll say the design is safe. In shear also. So there are two major possibilities for a screw to fail. First is its principal stress, and second is its basically shear stress, and both the way we have seen that they are going to be safe, and hence the design parameter, the found out parameters are safe in design. So let us move ahead with finding out few more parameters which are associated with the screw, basically the length of screw. So we know that length of screw, again you can find this relation, empirical relation with the section of power screws, and it says that L is equal to 350. 350 is basically the given height which we have to raise the weight to, plus I'm directly writing it 350 plus h by 2. H is the height of the screw that we have considered. So the total thing comes out to be 388.2 millimeter. Now this particular thing, length, can be configured to even decimal things, and hence it is a possible dimension. Next thing that we have is the pitch or the associated dimensions of power screw. We know that N here is 4. Let us take N is equal to 4. And the formula that is for the crushing load or the bearing load or bearing pressure is given as, again you can refer to the PhD data book, and it says that it is somewhere around 855 times 260, which is its yield stress, divided by the T thickness plus FOS by 4, which is your N, into your length divided by tau square. So if we substitute back the values in this particular thing, we'll get value of PC somewhere around 206.99 into 10 raised to 3 Newton. So that is the amount of crushing value that's acting on the screw. So there we have found out this value which the screw can actually take up. So this was the end of the part 2, where we have concluded with the design of screw. In the next part we will be designing the horizontal section of the screw press, which is very important part. Thank you so much for watching this video. If you like this video, please subscribe to Ekeeda